Hey everybody, I'm making a YouTube video again. I know it's been a long time. I've been extremely busy. This is our main field season for work, so I've been doing a lot. I've been at sea quite a bit, and then doing other projects. And then when I have free time, I just tend to be like lazy or go hiking or play disc golf, something. I just been making YouTube videos has been kind of low on my priority list, and I apologize for that, but we'll see how if it continues into the future or not. And I also, this is kind of exciting, I got to participate in a very exciting documentary film project. You know, like those projects they do where people are made to wear blinders and then live for a certain amount of time as a blind person, or they darken their skin and live like a black person in the South, and these kinds of things as an attempt to understand what that person's feeling, or how a group of people feels, and get a better sense of it at least. And I got to participate in one of those. This was called 30 Days of Hasselhoff, and this was an attempt to empathize a little with David Hasselhoff and how his life. Here's a short clip.
Because if you get alcohol tonight, you're fired from your show tomorrow. And the doctor is coming over here in the morning to check your alcohol level. And if you have any alcohol in your system, you're going to be fired from the show.
So anyway, I just was being an idiot. I'm not. That was a joke. I never participated in any such documentary film. I mean, it would be a silly thing to do. Unless I guess somebody could start the Hasselhoff challenge. But anyway, that's an aside. So I am making this video in response to OnceForgivenNow's free video on homology, which you won't learn in the textbooks or something. I probably butchered the title. I'm sorry. I'm going kind of from memory here on this. So if I make some errors, I do apologize to the video maker. Anyway. So this video is about homology, and again, obviously, derp. And he goes into a lot of detail about from textbooks looking at this. It's kind of a standard thing. I did notice, by the way, that I'm making this to you, I suppose, that your textbook examples and graphics are the same ones that have been used by Hovind and Russ Miller and others repeatedly. And I'm not sure if it's just coincidence that you happen to have Modern Biology 2002 edition, or if you're just borrowing the graphics. But anyway, I recommend, if you're going to do things like that, buy a more recent one. I mean, you can get them for really cheap. You can get last year's grade school textbook or whatever, or high school textbook for just a couple of bucks on Amazon used, if you wanted to. Just kind of suggesting that. So I'm going to let you start here, and I'm going to talk about some of the errors that I found in your presentation. So here you go.
Let's start off with the textbook Modern Biology, which has a section on the evidence for evolution. It states that similar features that originated in a shared ancestor are described as homologous. We can then look at the sketch they give us and see that the penguin, the alligator, the bats, and humans, they all have similar bone structures. First, there's a green one, and then there's a purple one and a pink one. Then there's a little blue one. I mean, the similarities are just overwhelming, right? And if we look to the right, we see that the bones even have the same names. Pretty amazing, huh? Obviously, they're similar because they're related, right? Now, any rational person needs to stop here and notice that similarities, or homology, doesn't prove that they evolved from a common ancestor. It just proves that they're similar.
Okay. First mistake that you make here, okay, is looking at those bones, and they're not homologous because the illustrator colored them green and purple and such, and they're not homologous because they have the same names, okay? They're not homologous because they're similar. You make a pretty big major error here, and I don't know if it's deliberate or not, I don't think so, is that the word similarity or similar is in the definition of homology. It's contained in that description of homology. But those terms are not equivalent. You can't use them interchangeably. Okay, that's an important point to make, and I think it will make more sense when I get to the next thing. Excuse me, holy smokes. Okay, now this is it though. This is something that I've seen a lot of creationists doing. Now I don't mean you. I mean creationists like in, Ken Ham. And in fact, Hovind did his fair share of this, but these guys have perfected it to an art, which is to give the general impression to their audience. Because, you have to admit, those audiences that you see on these big lecture halls and things, are they're church groups. They're meeting halls filled with church groups and such. Okay, they're not speaking before scientists. They're not going to scientific conferences and doing these presentations. They're not talking at universities for the most part. They're presenting these things to people who already accept the premise that they're making, and they also know that entails a really, and this is not an insult on creationists, but if you deny that it's true, I don't know what to tell you. That there is a good amount of scientific illiteracy amongst creationists. And that doesn't mean that all of them are scientifically illiterate, but there's a great deal of it in that group. So when they make these things and they make these huge errors and logical errors and stuff like that, and people accept it, they wouldn't get away with that if they were speaking at a scientific conference. That's just what I'm saying. But anyway, wow, I'm just going off on tangents. I don't know why anybody wastes time with my videos. But anyway, but what they've been doing is they've been trying to get across the idea that scientists that do this work, paleontologists, evolutionary geneticists, these people that are constructing phylogenies of groups and comparative anatomy and working specifically with evolutionary biology, are really just armchair philosophers that never actually see the material that they're working with. They just think of these neat ideas. Oh, I have a great idea. What if chickens evolved from alligators or something like that? And then they write a paper and they get $1 million grant or something like that. That's this idea that they're trying to present. And it sort of fits in this kind of colloquial idea of what a scientist is. It milks the ego of their audiences. But scientists they don't walk up to a table and look at two bones and go, why, they look kind of similar to me, I bet they evolved from one another, and then they walk away, case closed. Okay? The stuff is done with absolute intent measurements, and they may be incorrect, their conclusions may be incorrect, and they often are. But that's determined by their peers, that's determined by other scientists. Okay? But they have a hypothesis, they come up with a method of testing that hypothesis, then they examine their material, they publish their paper, and that paper, even the most innocent, non-controversial statements, can be shredded by their peers. Okay? It's a pretty cutthroat world, and your worst critics in science, I publish science papers, your worst critics are your own peers, your own people who have their own ideas. I don't work with bones. I don't work, that's irrelevant. But the point is that you can say the most innocent thing, and if your conclusion is not supported, because other scientists will run your numbers. Okay, they will go through that supplementary material that you publish along with it, and they will crunch those same numbers. And if they find a math error, if they find it's that kind of thing. It's a very difficult and somewhat unpleasant process getting a paper published. So, you have to understand that if these scientists were making this blunder, like looking at a bat wing and a whale flipper and going, wow, they look kind of the same, they must be related to each other, and that's as far as they went with the research, it wouldn't hold up very long. And that's kind of what I'm saying. But the point is that these things, that's not what homology is. It's not just simple, gross similarity. Okay? It's similarity in arrangement of the bones and the muscles and the tendons. It's similarity in development, how they grow. And I'll get to this because you make this point incorrectly later on. It's similarity in the regulatory networks and the genes that control those kinds of development. Okay, Tetrapods all have a nearly identical gene cascade that leads to limb development, almost identical. It changes there's a few little changes here and there, but that makes sense because things are added on top. A fish's fin has a certain set of the genetic toolkit to grow the limb bud. Tetrapods, mammals, reptiles, birds have that same set, but then they have an additional set that thing starts growing the long bones. And I mean, it's layered on top of each other, with the old one still present and still functioning. We still grow a fish's fin for all intents and purposes. It's just that then it's further modified with more complex genetic machinery, that kind of thing. And tetrapods use the same genetic machinery for the most part to grow, whether they grow a limb and it atrophies back. Whales have hind limbs that develop. They have the same genes that we have, that hippopotamuses have, or whatever, to grow hind limbs, but then they're reabsorbed. So they go through that whole same process growing hind limbs because, well, they evolved from a terrestrial ancestor. And I know that that's an assumption, but I think the evidence for that is about as compelling as any evidence can get. Anyway, but that's wow. Anyway. So I'm going to let you go on here because you show what you believe to be a logic contradiction.
Now here's where the textbook shoots itself in the foot. Here it states that sometimes organisms that appear to be very similar, such as a shark and a porpoise, are not closely related at all. Wait, isn't that the exact opposite of what they just said? See, what they're basically saying is similarities are evidence of common ancestry, except for when similarities are not due to common ancestry. How is this evidence for evolution?
Okay, now this is it. This is what I was talking about. You use the word similar in place of homologous, and then claim that they're contradicting each other. Do you see that? That's not what's going on. Okay, they're talking about the difference between analogous and homologous structures, or body plans, or those kinds of things. A shark and a dolphin have a really grossly similar general body shape, but they're not similar at all, and I hope you recognize that. They're not in any way. Nobody open them up, dissect them, look inside of them, look at the parts. The dolphin has pretty much all the same parts as any other mammal does, with a few little exceptions, and a few parts tweaked or elongated or changed in shape or atrophied. But they have all the parts of a mammal. You open up a porpoise and it's clearly a mammal inside. You open up a shark and it's clearly a cartilaginous fish inside. Completely different structures of the limbs, completely different. I mean, they differ across the board. The only thing they have in common is that long, elongate, kind of submarine-shaped body that works really, really well for moving a large-bodied animal quickly through the ocean. And that's why they're similar. That's it. Okay? It's not a matter of, well, we know, nobody looked at a dolphin and a shark and go, oh my God, they're practically identical, but this must be convergent evolution because we know they're not related. That's what you're trying to say, and that's completely deceptive and completely false. I'm sorry. That's pretty terrible in my opinion. You're spreading a false idea of how science operates and how science works. Anyway, so now let's get on to the genes because, I think you blow everything, the whole concept of genetic homology out of the water with this.
Now some evolutionists hope that genetics would clear up this problem, since perhaps homologous structures would develop in similar ways. Well, Sir Gavin de Beer, an evolutionist, wrote a book titled Homology, an Unsolved Problem. Here's what he has to say. Because homology implies community of descent from a common ancestor, it might be thought that genetics would provide the key to the problem of homology. This is where the worst shock of all is encountered. Characters controlled by identical genes are not necessarily homologous, and homologous structures need not be controlled by identical genes. Sounds like a failed argument for evolution, yet it's still in the textbook.
I don't know what to say. I mean, that's amazing. I mean, that's cutting edge genetics right there. I mean, that is the forefront of the field of genetics and development and evo-devo stuff right there. And he says that there's no connection between homology and the genes. I'm going to have to rethink my whole outlook on life. Okay, I'm sorry. Use a little bit of sarcasm here and there, so I thought I'd do that. I'm not trying to be rude. Do you know when that was written? In fact, here, let's start with this. Did you read that book? Did you read it? Did you read Gavin De Beer's book? I haven't read it. I've read a lot. In fact, I've read probably, I'd say, an enormous amount of what's been published in at least landmark evolutionary biology literature. I've never read that one. It's a pretty obscure book. And but I have read, actually, I've read several pages from it. I took developmental biology, and we had a lot of we had photocopies of certain pages in that book. But mostly as a looking into the history of these kinds of things, not as a modern thinking, because that book was written in 1971. Did you know that when you cited it? Or did you just find it on a creationist article, one of Jerry Bergman's or one of those other, well, I won't use the term that I want to describe Mr. Bergman. But that's 1971. That's 43 years ago that book was published. Do you think that he published that book and then we all just geneticists just closed the books and walked home from their labs and became fry cooks or something like that? Because, well, he said it, that's all. There's no more progress in science since then, not in 43 years. That was the barest, rudimentary beginnings. That was I don't even know. Sputnik, in terms of astronomy, or in terms of space exploration. Okay, it was so rudimentary at the time when that was written. I mean, this is when they would just take chunks of chromosomes out of a fruit fly embryo and plant it somewhere else and then see what happened if it grew, a leg on its ass or something like that. That's the kind of work they were doing then. They weren't mapping genes. They weren't sequencing genomes and determining gene function, or they weren't looking at cascade effects and gene regulatory networks. They didn't have the technology to do that when he wrote that. He was speculating, and he was wrong. And just a very few years later, he was shown to be wrong about that. Okay? It's an interesting little piece of history. It was thought that, because what he didn't know was that we would discover these whole Hox gene toolkits and how they can influence major changes in body plan from almost anywhere. What that means is that you can cut and paste the instructions, if you will, for an organ somewhere else, and it will grow in that place. So when we have homologous structures, sometimes those have been shifted around because chromosomes break apart and redo. They don't put the organs in a different place, but they develop from a different part of the chromosome. And that's what he was noticing. That's what they had noticed at the time. It's like, this is on this chromosome on this fly, and this is on another chromosome on that fly. Therefore, they're not truly homologous because they're developing from different genes. Now we know that they are homologous because we can sequence them, and that section of the one chromosome just moved somewhere else. Okay, does that make sense? And we know it moved somewhere else because it's got all of the other pieces, including all of the junk and fragments and ERVs and everything else contained in it, literally snipped and cut somewhere else. Okay. Okay. So anyway, you really, really need to check your sources before you cite them as some absolute, blow to evolutionary biology. All right, and now you end with a quote from Michael Ruse.
Let's end off with a quote from the atheist philosopher Michael Ruse. Evolution is a religion. This was true of evolution in the beginning, and it is true of evolution still today. Hey, I'm not the one who said it.
All right, again, I don't think that you're reading the National Post from Canada, year 2000, to have read that article yourself. I think you found that quote on the millions of creationist websites where it's been posted. Evolutionist admits evolution is a religion and this kind of thing. But I don't think that that's very honest, because of the fact that, first of all, that was a book review. It was a book review written by Michael Ruse, and in that review, and I don't even know what book it was because I don't have the whole article. I have Michael Ruse explaining it. I have a little essay he wrote slamming creationists for using that quote because it's deceptive. But what he's talking about there is he was talking about the new atheist movement, and how, aside from the science of evolution, aside from the research in evolutionary biology, that these people, the new atheists, are somewhat embracing a conceptual, a philosophical idea of evolution as a replacement for religion. And he was opposed to that because he thinks that religion has a perfectly fine place in society as long as it doesn't conflict with society. He's not part of that religion is a disease that needs to be stamped out movement. And I think you would agree with that. I agree with that. I'm not a big fan for the most part, even though I can agree with portions of what they say of the new atheist movement. The so-called new atheist movement. It's not really new. But that's what he's going on about. He's going on about this idea, and Huxley kind of started it back in Darwin's day. Huxley, had this idea of evolution involved everything improving itself and getting better and bigger and stronger, kind of like a replacement of Christianity where we'll be elevated to divine spiritual status, that we're all moving upward through some scale of being. And he thought that as some kind of a replacement for religion and Christianity. And a little elements of that, Michael Ruse was slamming the new creationists for incorporating sort of vague notions of that idea into a philosophy when evolution is a science and should be kept in the realm of science. That's what that was about. That's what he's talking about. He's not talking about that if you support the theory of evolution, you're believing religious dogma. He's talking about people who use the theory of evolution and they treat it as a religious dogma. That's what he's talking about. So anyway, again, check your sources, look this stuff up. It's all widely available. And if you PM me if for some reason you need PDF files of this stuff, if you do want to start checking your sources, I every single time I watch any creationist video, I get the citation and I'll either look it up on our database, or I'll interlibrary loan and get a copy of the PDF. So I have an enormous library of PDFs that these creationists used and cited, so I can read them myself and see what they have to say. Some I'm still working on tracking down, but I have a good number of them, and I'm happy to share them if you would like to actually, vet some of your statements before you make them in front of your audience. So, okay, have a good one. Take care. I'll probably see if I can post this as a video response, and you have a great day. Bye.